Hello and welcome to my ENME351 Lab 9 final project. So for my project, I made my own custom continuous rotation encoded brushed DC servo. So I did this using a brushed DC motor, a very cheap and small one that normally operates at very high RPM and low torque. And then I designed and built a 1 to 625 reduction planetary gearbox and 3D printed it. And then the output of said gearbox is being encoded using a mechanical incremental continuous rotation encoder. And so I did not actually have a controller for this motor, so I wanted to build my own. Initially I tried to use transistors. You can see the remains of my initial H-bridge over there. However, while this worked for the motor unloaded outside the gearbox, the friction losses introduced by the gearbox were high enough that it raised the current from being around 200 milliamps to being about 1.5 amps, and the BJTs I was using just could not handle this kind of current. So I applied the H-bridge principle to a different switching circuit, and that is these electromechanical relays I have here. So these 4 relays are doing exactly what a transistor H-bridge would do, and that's actually how I'm controlling my motor, which is quite nice because their internal resistance is basically negligible because it's just direct metal contacts, and I don't risk damaging my controller. Output from the Arduino is being fed to this processing code, which is showing me my set point, my actual position as measured by the encoder, and my speed as measured by the encoder. So the control loop here is quite simple. I'm setting the set points using these 4 buttons over here, which give me a slow and a fast jog in both directions. Then the motor is told by the Arduino to turn to try to meet that set point, and it turns until the encoder tells it that it has advanced sufficiently close, I said within 4 ticks of the desired set point. Once it is there, it stops, and it can do that in both directions. And we are measuring speed by taking the number of ticks, dividing it by the time between readings. And because the initial reading is quite noisy, we're actually doing a 10-element moving average. So now let me just demonstrate the circuit for you. So I'm going to take the motor and stabilize it in my hand, and a slow jog, and slow jog reverse, and then fast jog. And a fast jog in reverse. As you can see, the motor is very noisy, but it does actually do the job, and the control loop works quite nicely. Thank you very much, and have a nice day.